Welcome. Today we are diving headfirst into one of the most mind-bending technologies out there, brain-computer interfaces. And let me tell you, this is a journey into the very, very near future, where our thoughts will literally control the world around us. So just think about this for a second. Imagine controlling the world around you, not with your hands, but just with a thought. Changing the TV channel, moving a wheelchair, typing out an email, all with the power of your mind. That's the incredible promise of a BCI. It's basically a universal remote for your reality. So, here's how we're going to break this all down. We'll start with what a BCI actually is. Then, we'll get into how it listens to the brain and turns a thought into an action. From there, we'll see the unbelievable impact it's already having on people's lives. We'll look at the global race to master this tech. And finally, we'll face the really tough ethical questions that we absolutely cannot ignore. All right, let's jump right in with the basics. I know, this whole thing sounds like it's straight out of a science fiction movie, but the concept itself is surprisingly easy to get your head around. You see, at its core, a BCI is basically a translator. Normally, if you want to click a mouse, your brain sends a signal down your arm to your muscles, right? Well, a BCI just skips that middleman entirely. It creates a direct line, a bridge, between your brain's electrical signals and a computer, letting you command technology without moving a single muscle. Okay, so if we're going to build that bridge, the first big question is, how do you actually hear what the brain is trying to say? Well, it turns out there are three main ways to do it, and each one has its own pretty serious trade-offs. And these analogies, they make it super easy to understand. First, you've got invasive BCIs. Think of it like planting a tiny seed right in the brain tissue. You get the absolute clearest signal, but, yep, it requires surgery. Then there's semi-invasive, which is kind of like putting a sticker on a window. The sensors just sit on the brain's surface, so it's much safer, but the signal quality, it takes a hit. And finally, there's non-invasive. This is like trying to listen through a really thick wall. You just wear a cap, it's totally safe, but your skull kind of muffles the brain signals. All right, so we've got the signal. Now what? How does that electrical whisper from your brain actually turn into a real-world command, like moving a cursor on a screen? Well, it's a pretty amazing four-step journey. It all kicks off with the spark. That's you just intending to do something, which creates a tiny electrical reaction in your brain. Then comes the capture. Super sensitive sensors, whether they're inside or outside your skull, pick up those little whispers. Next, and this is the really cool part, the translation. An AI algorithm deciphers those whispers, figuring out what you actually want to do. And finally, the action. The computer carries out the command. And just like that, thought becomes reality. And to really get your head around that third step, the translation, this analogy is just perfect. The AI isn't reading your mind like a book, not at all. Instead, it's like a toddler that, over time, learns to recognize patterns. It learns that this specific jumble of brain signals means move the cursor left, and that pattern means click. It's all about learning and pattern recognition. So, we've been deep in the technical stuff, the how, right? But the why, oh man, the why is where this technology becomes truly profound. This isn't just about playing video games with your mind. This is about restoring dignity and fundamentally changing people's lives. And the applications are just staggering. We are talking about giving people with paralysis the ability to operate robotic limbs just by thinking, or giving a voice back to those who have lost the ability to speak. We're even using this tech to understand and monitor our moods, which could be a total game changer for mental health and for people in high-stress jobs. But hang on, let's just stop on that one for a second. Reconstructing images from the mind's eye? Look, it's one thing to see what a person's eyes are looking at. It is another thing entirely to pull an image that exists only in their imagination and put it on a screen. The implications of that are, well, they're just staggering. And please, don't think for a second this is some far-off, 50 years from now kind of thing. No way. This is happening right now, and it is moving at lightning speed. We are in the middle of a global race to bring this technology to all of us. Get this. That's the window. Experts believe we're going to see widespread BCI products out there on the market in just the next 3 to 5 years. That's how fast this whole field is exploding. And you know what follows that kind of innovation, right? Money. A lot of money. The market for BCIs is projected to soar past $800 million by 2027. That is a huge signal that some of the biggest players are pouring massive investment into this. And this isn't just a commercial race between companies. It is a strategic one with huge geopolitical stakes. When a country like China elevates a technology to the same level of importance as 6G or even nuclear fusion, it's because they see it as absolutely fundamental to their future. The future isn't just arriving, it's being built right now. Okay, so with all this incredible, world-changing potential, we absolutely have to talk about the other side of the coin. Because with this much power comes some profound responsibility, and we have to face the massive ethical questions of hooking our minds up to the digital world. So, as we're all standing here on the brink of this whole new world, what are the biggest risks? What are the tough questions we need to start asking and solving together? Well, here are some of the big ones that keep people up at night. First, mental privacy. It's a huge one. If a company has access to your brain data, who actually owns it? Then there's the terrifying idea of brain jocking. Could a hacker literally get into your BCI? And what about work? Could your boss one day monitor your focus or even your stress levels in real time? And all of this really boils down to something called your brain print. You see, your brain's activity is so unique to you, it's actually more identifiable than your fingerprint. But here's the crazy part. Unlike a fingerprint, your brain print can reveal your feelings, your biases, maybe even thoughts you haven't spoken aloud. This isn't just data. It is the most personal, intimate information that will ever exist about you. Now, the good news is we're not totally unprepared. Forward-thinking people and even entire countries are already working on solutions. Places like Chile are pioneering this idea of neurorights, creating brand new laws to make it clear that the data in our heads, our mental privacy, our freedom of thought, is a fundamental human right that has to be protected. And at the end of the day, that is what this all comes down to. This one huge question. As we build this incredible bridge between the human mind and the machine, we have to decide, together, what the rules of the road are. Who should own the thoughts in our heads? It's a conversation not just about technology, but about what it means to be human. And it's a conversation we all need to be a part of. Thanks for joining me on this one.